Okay? Get to work on trying to find that middle 99%. Okay, I'll give you a minute to get started. I'm going to pause this. No, I can't pause this. 102. Sorry. That sound better? Or look better? That chart? You know what? You got the chart right here, right? You have it circled on there too for them? Or is that a different one circled? Maybe we could look on the other side of the chart.
It's here.
Oh, I don't want you to circle it. You don't have to circle it. Yeah. Let's see. What are you looking for in the chart?
99.5%.
99.5. Which would be 995?
Oh, it's over there. It's over there.
Like right in between here? 99.5. So, right, this is 2.57 here. This is 2.58 here. How about 2.575, like right in between the two? That's going to be our Z. It'll work out the same negative and positive. So imagine right in the middle is our mean. That's where that 0.558 is going to be. I might round it to 0.559, something like that. Bless you. .5%, 0.5% up there. I think they did those calculations for Z. That looks good. So this is our mean here. How do you know your interval? How much up and how much down do you need to go from your mean? You have your Z-score. So we need to know I think we need to know our standard deviation, right?
Yeah.
Because before in class we were going 2 standard deviations. This is about 2.5 standard deviations. It's a little more than 2. So standard deviation formula. I got it.
Is it really 2 times 2.575?
2 times point.
It's Z. Z score.
Z equals 2.575. So we need 1 standard deviation so that we can calculate 2.5 standard deviations or a little bit more standard deviations. Which formula do we use? So P was 0.5588. 1 minus P was didn't we just do this one? 0.4412? Because when we were calculating over here, it's the same type of numbers. And then it's divided by N, right? The number that we're using? 102, isn't it? Not the 57, right? It's the total number. All right, so let's do some calculations here. Capability times 1 minus the capability divided by the number that you have in your sample. We have 102 in our sample. Probability was the 57 over 102. 57 were 10 years older. 57 over 10 of the 102.
So that is impairment.
All right, gentlemen, you're doing a lot of ruckus over there. You figured it out? You got it yet? Or are you just waiting for me to do it?
Yep, I got it.
You got it, Adam? Let's hear it.
0.0491638477.
I got something exactly like that. I'm going to stick with 0.049. Okay? Any questions on how we got to that point? Feel free to ask now, because that's going to be the standard deviation that we're going to be using there. So we want to go up 2.5 standard deviations. So if one standard deviation is 0.049, double it would be 2 standard deviations. We need 2.575 standard deviations. So what should we do with these numbers? Sounds good to me. So if we multiply them, then this is going to be our margin of error. 2.575.
So it's like plus or minus 12%.
You got it. So right now our margin of error is 0.126597 or around 12.7% is sometimes how people would be saying it. And that's kind of what we're going to get to for the next one. But 12.7%, I think I put what's the margin of error. So that's the margin of error, which we have to calculate anyways. So now from the mean, we're going to be going up 0.126597. We're going to go down 0.126597. And you don't have to use the whole entire number. It's okay. I noticed from what I have and from what the book has, they're using 2 decimal places. A lot of times I'm using 3 decimal places. So it just depends. But as long as you're right in the realm of things, it shouldn't be too far off. So what'd you get as your interval?
0.4218.
All right. So what's the bottom end if we were to take away?
0.4318.
It definitely should be in the 4s. Let me just do my own math too, just to double check. All right, Adam. Let's hear it again.
0.4318.
Yep, I got 0.432, but I'm going to stick with just 0.43. That's fine. Now we want to take that mean and add the margin of error. Did you know your calculator will control copy and control paste, control C and control V? Pretty cool, huh? All right, Adam, what'd you get?
For the top end,
Yep.
0.685.
Yep, I got 0.69. You got it. So for this one, we got from between 0.43 and 0.69. It's going to be our 99. We're 99% confident of something. What are we confident of? We have to be confident of something in that. So we've got to write that whole sentence. Captures the true proportion. I've tried to word it in another way, and it's very difficult to word it in another way. So everything that I've been seeing on the AP exam, any questions, the answers are always the same. We are 99% confident. Because I'd like to be able to, put it in my own words, but it's not going to be in my own words. It's not going to be in your own words. from 0.43 to 0.69, it's supposed to be captures the true proportion of, and this is where you have to interpret in context, which means you got to put the pennies in there somehow. Captures the true proportion. What were we measuring?
Number of pennies that were 10 years old.
10 years, more than 10 years old, right? Of pennies that are more than 10 years old. So now this is just review, so it shouldn't have been brand new, because this is just review from last time, where we're finding the borders, trying to calculate how many standard deviations we need. So we do a percentage of the standard deviation. This one we wanted 2.5. We times by 2.5%, or 2.5 of the, for the z-score to find out how many standard deviations we wanted. Now, margin of error was down there. We had to calculate it and add or subtract by it. How many pennies must we sample? This is the new stuff that I wanted to make sure that we talked about. How many pennies must we sample to have a margin of error of only 5%? Because right now our margin of error is 12%. Yeah. We need more to sample, and then our margin of error is going to come down. We'll be same amount of confidence, but we'll have this error possibility less and less. So 12.7% is like a bigger margin of error. Typically, you want to be around 1% or 2% is what's going to normally happen. This was 12%. So we want this now to equal 5% instead of 12%. We don't have much change. We can't change much the probability because we still have 57 of the 120 or 102. That's what we have to go on. And we still can't change something like this. But the amount that we sample is what we can change within there. So we got to think of, okay, maybe if we tested more pennies, we'd have a better percentage that would be more accurate. Might change those percentages for right now, but we'll leave them. And we're just going to calculate, saying maybe we could change the sample size and see what will happen to that margin of error. So think about all this work that you did to find the proportion. This was all this work to find the standard deviation. Sorry about that. And we had to multiply it by 2.575 to get that margin of error. So I don't want to take that away either. I want to leave that within there as well. But I want to take out this 102 for the number of sample that we're using and put an N there. So we might need, if we had more to sample from, we would actually be able to change that margin of error. What do you think?
If we change the number that we're sampling,
There probably will be, but then we're going to still use that same proportion.